Hello, Space Cadets, and welcome to Mueller Planetarium, Astronomy at Home. This is Zach Thompson, Planetarium Coordinator at the University of Nebraska State Museum at Morrill Hall in Lincoln, Nebraska, wishing you all clear skies. Today we're going to explore exoplanets. We'll be using NASA's Eyes on Exoplanets, a free software that you can download on your computer at home. Look to the right of your screen for the web address eyes.nasa.gov, being held up by our large Earth buddy. An exoplanet is a planet that is beyond our solar system. The full name is extrasolar planet, but it's easier to say exoplanet. The search for them began officially in 1995 with the discovery of the first exoplanet going around a star like our Sun. That star is 51 Pegasi. It belongs to the constellation of Pegasus, and if we zoom a little ways out, we can see the planet that was discovered, 51 Pegasi b. It was then nicknamed Bellerophon, and it's now officially called Dimidium. But there it is, the first one that we discovered. Well, how do we find exoplanets? That's not easy to do. Planets are very small compared to the stars that they orbit, but there are a couple of widely used methods that have been very successful so far. The first is called the transit. When we're studying a star, we can measure the brightness. But occasionally, that brightness might dip for a certain period of time. And then the brightness goes back to normal, it dips, then back to normal. And that is because something is crossing in front of the star. From our perspective on Earth, we say that the planet is transiting the star, blocking some of that starlight. In fact, in our own solar system, the planets Venus and Mercury transit in front of the Sun from our perspective on Earth. And when that happens, indeed, the brightness of our own Sun dips by a measurable small amount. That's one method. The other uses the Doppler shift, or the Doppler effect. You might not be used to the name, but you're definitely familiar with the phenomenon. Imagine, by using this diagram from our friends at NASA Goddard Space Flight Center, that you're standing still on a sidewalk, and then you hear an ambulance in the distance, and it comes towards you and passes. So here's a really crude representation of that. Bad, I know, but bear with us, because hopefully you're familiar with that experience of something getting close and loud and then going far away and getting softer with sound. And what's happening is the sound waves are getting closer to you, they're compressing, so it sounds higher in pitch. Then the sound waves stretch out as the ambulance passes you, and they're no longer compressed, so the sound is stretched out, it's softer and lower in pitch. Now we can apply this to starlight. When we're looking at stars, we're studying them, we can determine a planet is there. A planet uses its gravitational influence to ever so slightly wobble the star that it's going around. When the star wobbles a little bit towards the Earth, we say it's blue shifted. The light is a little bit more compressed. When the wobble shifts the star a little bit farther from us, it's red shifted. The light from the star is stretched out more. It's very handy, and using those two popular methods, we can then determine things like the size of the planet. We can get snapshots of the planet's atmosphere when it's backlit by the star. We can figure out the density and even the composition of the planet. Is it a gas planet or a rocky planet? Those are very popular because of what we can determine from them, though there are a few other lesser used, at least at the moment, methods of discovering this planet, but those are the two best. Using Eyes on Exoplanets, you can then explore in greater detail all the planets that we have confirmed so far, these confirmed exoplanets, which are more than 4,000 now. All of these little dots, these starry light dots right here, represent a star with at least one exoplanet. You can just click one at random, like we're doing right now. You need to be connected to the internet when you use this so that you can get updates regularly. We do determine that there are exoplanets, or we make new discoveries practically every day or every week or every month. It really is an incredible field of astronomy that's always changing because we keep finding more. So internet will help you here when you use this visualization software. So we picked one here at random. And here's the star, and here is the planet. You can double click on the planet to see what we think it looks like based on either the transit or the wobble method. So here is a good guess at what we think it looks like. To the left, when you click on a planet, you can learn a little bit more compared to maybe things like planets in our solar system or the size. So we have this big gas planet. Let's compare the size to the Earth. You see, it's bigger. But then we can compare it to the size of Jupiter, and it's not quite as big as Jupiter. We can also click on habitable zone, and it looks like this donut. The habitable zone is where the Earth is going around the sun. It's not too close or too far from the sun so that liquid water can exist on the surface. As far as we know, liquid water means that there could be life. At least it's a good indicator for the possibilities of life. So we turn on the habitable zone for this particular star, and you see that the planet that we identified, it's much too close. So it'd be way too hot. Liquid water would just boil away. It wouldn't be there at all. With more than 4,000 exoplanets, you can spend quite a bit of time just clicking around at random. You can then figure out what mission led us to these discoveries. And there are several, in fact. It's not really just one, though one in particular does stand out because it really opened the floodgates on exoplanet discoveries, and that is the Kepler Space Telescope. This really showed us how many exoplanets were out there. Thanks to Kepler, we now know that for every star in the galaxy, there must be at least one exoplanet. That's at least the ratio. There is at least one planet for every star in the Milky Way, and in our galaxy, there are anywhere between 100 billion and 400 billion stars. So there are a lot of planets out there indeed. Looking here at what Kepler looks like, you can then swing around and you see this grid. That's one of the primary areas where Kepler was focused on finding exoplanets, looking in a general region of the sky. Kepler is no longer functioning, however, the mission does continue because researchers are still going through all the data that it compiled. What we need to do here on Earth then is we look at candidates that Kepler found for planets, and then we verify whether that's the real deal or not using ground-based telescopes. So that's why the number of exoplanets usually rises quite frequently, because we're confirming Kepler discoveries. Kepler is no longer functioning, but there are several other missions out there. One in particular is called TESS, the Transiting Exoplanet Survey Satellite. This covers a wider region of the sky, but it's one of the hottest topics in astronomy to this day, exoplanets. Really explore on your own. Go on a safari of exoplanets. See how many are similar to Earth, larger than Earth, super-Earths, larger than Jupiter. Really, it is an incredible catalog of the diversity of planets. And something really fun, if you're a fan of Star Wars, you can see some worlds that we have found to resemble those in the Star Wars universe. In particular, Hoth from Empire Strikes Back. We have found a frozen world that resembles Hoth. We've even found a couple of planets that are like Tatooine, going around a star system of at least 2 stars. Science fiction meets science facts. On your safari, on your journey using eyes on exoplanets, please keep in mind, if you have any questions, this is a good place to ask them in the section below in case you get lost. You can always click on the home button to take you back to your overall view should you get really lost in the weeds, so to speak. But really have some fun with eyes on exoplanets. Until next time, Space Cadets, happy hunting and keep looking up.